Yeah, g'day. Today we're going to cast some pistons for my 1920 Redrup Radial motorbike engine replica. I'm trying to build a replica of this engine from only 2 plans and 5 pictures. So let's hope it all works out. First of all, thanks for all the excellent inputs and advice you guys gave to my piston core mold issues in my kickoff video. I'd been having difficulty getting my sand cores to release cleanly from their mold. The suggestions I got fell into 3 areas. 1 was improving the mold, 2 changing to a different casting method, and 3 was machining from billet. Now, a number of you correctly identified that my cores hanging up was a draft problem and not a fillet radius issue. I first reacted that I'd already added draft to the pin boss and rib. However, when I checked the model in CAD, I noticed I'd only given those features 1.5 degrees of draft angle and the piston crown was flat. Oops, that's typically the minimum for an external feature. I discussed this with Martin, the old foundry guy on YouTube, and he recommended at least 3 degrees and more if the customer allows. So I made up a new core box with 3 degrees on the crown, 5 degrees on the pin boss, and 7 on that rib. By the way, some of you recommended putting a split line across the pin bore. That's not a possible geometry, as it would lead to a massive overhang and no release. The second group of suggestions pointed to improvements in my carbon dioxide gas flow to the most difficult corner. Now, I already had 3 canals for the gas to the pin bore, but I added extra canals in this version. Now, if necessary, I could also gas it for longer, like putting the core in a bucket of CO2. The third set of suggestions focused on changing casting method. Many of you suggested a change to epoxy-bound core sand. Just a quick aside, what are we actually looking for in a casting sand? It needs to be strong enough to hold the pattern form until cured, but then weak enough to break down as the part solidifies, because it shrinks during the solidification. There are a few common core sand binders. One is a baked core using like a sugar water. After molding, you bake the core in the oven to harden it. This is cheap and has the advantage of smelling like cookies. But the cores are very brittle when you first demold them, and they're hard to get out of the mold and only really take some strength once they're baked. There's also the time it takes to bake them, and don't get caught getting sandy sugar burnt into the cookie trays. A small amount of dilute epoxy also works. This will be stronger out of the mold and may well be necessary on some of the parts for this whole build, but the disadvantage is it takes a couple of hours to cure. And if you make that epoxy sand too strong and you've got a problem with insufficient draft, you're never going to get the part out of the mold, it'll just glue it together. I'm using sodium silicate, which hardens with exposure to CO2. This makes it a fast and easy way to iterate the mold design process. You know, I can do one, fail, do another, change something, it goes quickly. Some of you did suggest I switch to investment casting. That's a great method for something like a turbine blade, which has to have a very accurate geometry as cast. But for something like a piston, it doesn't really make sense because you're going to have to machine the outer diameter to a precise fit, therefore machining off any advantage that an investment casting would have. The second thing is investment castings are pretty expensive because the powder is quite expensive and you have to burn it out in an oven for about 12 hours up to about 750 degrees. So it's quite an expensive process. That's why I just concentrated on trying to improve the draft and the gas flow to my sand core. And as for machining from billet, well, it's really not trivial to actually reach down and machine small radius features, especially with undercut, this deep down in a part. I mean, it probably can be done, but you'd need pretty long, pretty skinny cutters with sort of a bulbous end on them. It's beyond my tooling and ability. But I'll leave a link to Martin, the old foundry guy's rant about machining pistons from billet. He summed it up very well. One evening after work, I set up my foundry out in my little garden shed and had a go at just trying out these patterns. Now, I don't have proper high silicon casting alloy for the piston yet, so this is just any old casting alloy. Also, the core I chose to use for this attempt is just one of the failed cores. It's one of the better ones, but it's not perfect. I don't expect to have a proper pin bore in there. Right, ready for the lift, and... This is the bit where I work out that I never actually made a pouring shank for the new crucibles which I bought off Amazon. So now I have to do sort of a half-ass pour using the lifting tongs. Oh, it's a little thing, but I got this gas can from somewhere and it's been great for holding fuel for my foundry furnace. But unfortunately, this vent cap broke. And I almost threw the thing out, but then I thought, wait a minute, how hard could it be to draw up a new one and print something out? And sure enough, wasn't hard at all. Thanks, Bamboo Labs. Success kind of looks different, so I think we'll call this an opportunity to learn. None of these castings completely filled. The reason for that is I poured too cold. And the reason I poured too cold, when I went to turn my thermometer on, it didn't turn on. I just had to guess the temperature and I guessed too cold. To add insult to injury, once I was finished, that thermometer was lying on my bench and it was on. I think it was trying to taunt me. And that's the piston. You can see how the core is supposed to work. The little 7mm gudgeon pin core has actually done its job pretty darn nicely. You can see how the cold aluminium froze before it rose to the top of the piston skirt. So what are we seeing there? Other than it not filling completely, core mould, the gudgeon pin especially, worked really nicely. The core I used was one which I had used epoxy to try and add more draft. It broke up the contours pretty badly, so it's a pretty ugly pin boss. There's also some defects on the outside. Don't know how far they'll go into the material or not, but all in all, I think it's a reasonable first attempt. I'm looking forward to getting the proper piston aluminium and trying it again with a little more temperature. The 3D printed runner's working nicely, I think. Yeah, for someone like me who doesn't have a huge amount of casting experience, you can really see the advantage of having something like Chastain's book to give me sort of almost a recipe of how to go about doing the gating and risers and stuff to get a good casting. Now, obviously this one's not a good casting, but at least it gets me a long way in the right direction. Big shout out to Martin, the old foundryman, for putting up his series on how to do pistons, because that really helped. Before the time comes to have another go at casting this, I'd better go ahead and make a pouring shank for this crucible. Okay, that's too big. Right, it's time to crank up my trusty Arc Captain TIG welder. The Arc Captain donated this welder to me, and I must say I've just found it fantastic. I'm in their affiliate program, so I'll leave a link below if you're interested in getting a TIG welder. I'm really happy with this one, and there's a bit of a discount for you, and they kick back a couple of % for me, so it's kind of a win-win because it won't cost you any extra, but it helps support the channel, so appreciate it. Should have dialed back on the heat a lot at the end there. There. I thought I'd ground the zinc off this, but I obviously haven't enough, so I'll give it another little grind. So thanks a lot, Arc Captain. Now when I do the casting, I'm going to need a flask which is exactly the same height as this, because I need to pull the runner from the bottom, but I need to pull the pattern from the top. I was looking through my old flasks, and look at this. This is what I made up a couple of years ago. Haven't used it yet, but it's near enough to perfectly the right size. Now it's a bit bigger than I was originally planning, because I was kind of thinking of doing 2 patterns per flask, with a flask maybe about this size. But since it's already made, let's make it work. I want the pouring basin to be close to the edge so I can pour without turbulence. So if we place that about here. Now with that highly detailed plan in mind, I'm going to now make up a match plate to mount the runners and gates and stuff onto, so that it's much easier to set up and mould those 3 piston moulds each time, because if I did it like laid out everything manually, it'd probably get a bit chaotic. Right, I think I've now finished my piston match plate. So the back just gets these 3 blobs which allow me to put a countersink in without going into the crown of the piston. And then on this side I've got my runners, and they connect to my 3 piston patterns which each have a alignment pin in them. It all gets sandwiched together like so. Even with better gassing and more draft, I was still knocking the ears off those pin bosses. Viewers had pointed out that when I open up the mould, I'm doing quite a lot of quite violent angular motion, which might be breaking those bits off. So to address that, I reprinted the mould with some 10mm holes in it. So left over from when I made my 3D printer, I've still got some 10mm rails. That one should be long enough. I chopped this in 2. This rod is hardened steel, so I can't cut it with the bandsaw. So with those 2 guide rods now installed, let's see whether the core mould now works properly, and let's see if it releases cleanly without sand getting hung up down in the little ear sections. This project's really helped by the precision of modern 3D printing. These holes were modelled at 10mm exactly, and then the whole core mould gets scaled by 2% to compensate for shrinkage of the metal, and those 10mm rails fit really nice, snugly but smoothly into the holes.
But everything that goes wrong, the government touches from here on out.
So I think I've got this mould pretty well sorted now. It's working quite nicely. Once you've got something like this dialed in, the mass production of cores goes pretty quickly, and therefore the whole casting process can go reasonably fast as well. This is another thing which speaks against using investment casting, because you need to print each part, mould each part in investment, let it dry, burn it out, heat it up, and then use it. With only one small oven, I don't really have a way to scale that process. Now you might think, I only need 3 pistons, how hard could it be? But realistically, I'm going to need more than that, because I'm sure I'm going to have some inclusions in some. I'm probably going to have some where I screw up the machining, or for whatever. It's easiest at the start, just set up for way more than you need, and then be pleasantly surprised if you have a couple left over. Right, well that's my 12th and hopefully last one of those cores. And there's my last sand core. Next good news. Scrap pistons that I can melt down. They're diesel pistons, so they have like a steel ring groove there, but that'll just melt out. So I don't know whether these were scrap or whether they were, superseded part number or something, but I really appreciate you guys donating 15 of them to this project. You know who you are. Thanks very much. So with a runner and sprue and a full mould, I'm guessing this is probably still under a half a kilo. And there's a half kilo, because that should be just the right amount of high silicon piston alloy to make 12 of my pistons. Using a match plate on a casting like this really speeds up the process because you don't have to cut the sprues and runners every single time. They're already just molded in there, unless you fail to connect to them with your ingate. These little 7mm pin cores have been surprisingly easy to work with, and they're reasonably robust. To weight down the cope, I put on these ingots of bronze, but unfortunately they're a bit too heavy to go directly on those cores. You'll see when I go to pour that the cores have been pushed down into the sand mould a bit, so on my later ones I switched to a different weight. So for this first mould, I poured it at about 680 degrees Celsius. And although the risers filled completely, I thought that might have been a little bit too cold, so for the second mould I tried 720 degrees Celsius. On this third mould, everything sort of turned to custard. It was filling, but only really slowly, so first I gave up, then I thought, nah, maybe it does work, maybe it doesn't, no wait, maybe it does. Yeah, nah. For the fourth and last pour, initially when I checked the melt in the furnace, it was only slightly over 700 degrees, so I decided to give it a little bit more heating. Man, that is hot, that oil burner, because literally a few seconds later, when I pulled the thing out again, it had added 50 degrees, so this one was poured at 750. Alright, how did that go? Well, this is the first pour. It was poured at 680 degrees Celsius, and as you can see, it didn't fill. So those will be going back in the pot. So these ones are the second pour. They were poured at 720 degrees, and it looks like they've filled up completely. We'll have to see whether they've got inclusions or something in them, but I think I got 2 decent ones out of that, and this one didn't quite fill. So 2 out of 3 filled. These ones will definitely move on to machining. And then we've got the third pour. I think I didn't get my main pouring tube or sprue properly connected to the gating. So you can see there's only a very, very little interface there. So it did start filling very, very slowly, but obviously too slowly. That's the one where most of the metal ran out across the concrete. That's a shame. Which leaves the last set, and these ones I poured at 700, probably closer to 750 even. Now these look like they may have porosity problems, too hot. There's probably some loose sand problems as well, but that should hopefully come out in the machining. There's also some shrink defects across the top there. These ones can move on to machining, but we'll see whether they're usable or not. You can see the core sand in this one's more a chocolate colour. That must have been one where I remembered to add a little bit of sugar to it to make it weaker and easier to remove at this stage. I cleaned up this one. It's got some sort of a defect down in here. Not sure if that'll clean up with a bit of a Dremel or something. They all look like they've got some porosity issues. So I've learnt that I need for this mould and this part probably about 720, maybe 730 degrees pouring temperature. But when I get that, it looks like I get a reasonable geometry on the inside. Parts seem to come out quite clean. Time will tell when I machine them whether I've got a porosity issue or whether there'll be useful castings out of there. I'll have to make up some more cores and then do another casting session hopefully sometime this week. But hey, at least they're worth machining, and I'll do that in a future video. Thanks very much for watching.